Download this code from codegive.com, link in the description below. OK, let's delve into chapter 6 to 11 of your Swift book, assuming you're referring to a book covering network requests and JSON parsing, perhaps something Swift specific, and how to use Codable to parse JSON results from the openweather API. I'll break down the process into clear steps with code examples. Understanding the goal. The core objective is to 1. Make a network request *, send a request to the openweather API to fetch weather data for a specific location. 2. Receive JSON response *, receive the response from the API, which will be in JSON format. 3. Parse the JSON *, use Codable to automatically convert the JSON data into Swift objects, structs or classes, that are easy to work with. 4. Use the parsed data * access and use the weather information, temperature, description, etc., within your app. Prerequisites. Xcode *, you'll need Xcode installed on your Mac. Swift basics * familiarity with Swift syntax, structs, classes, and optionals is helpful. Openweather API key * you'll need to sign up for a free API key from openweather map. Go to https://openweathermap.org/ https://openweathermap.org, and create an account. You'll get an API key, a long string of characters. Keep this key secure. Understanding of network requests. URL session. A basic understanding of how to make network requests using URL session in Swift. Step 1. Define the data structures using Codable. This is the most important step. You need to create Swift structs or classes that mirror the structure of the JSON data you'll receive from the openweather API. Go to the openweather API documentation for the specific endpoint you plan to use. Example: current weather data, https://openweathermap.org/current, https://openweathermap.org/current. Examine the sample JSON response provided in the documentation very carefully. Here's an example of how you might define the data structures for a basic current weather API call. Key points about Codable and the data structures. Codable protocol *. The Codable protocol is a type alias for decodable and encodable. Decodable allows you to decode JSON into Swift objects. Encodable allows you to encode Swift objects into JSON. Since we're primarily focusing on parsing JSON, we'll be using decodable most of the time, but Codable is convenient to use as a single protocol. Structs versus classes *. I've used structs in this example. Structs are value types, which are generally preferred for data models because they are immutable, safer. Classes are reference types. Choose the type that suits your needs. Property names *. The property names in your Swift structs should match the keys in the JSON data. If they don't, you'll need to use a coding keys enum, shown commented out in the main struct, to map the JSON keys to your Swift property names. Data types * use appropriate Swift data types, example int, double, string, bool. Optionals * use optionals, int, double, string, for JSON fields that might be missing or null. This prevents your app from crashing. The API documentation is crucial to determine which fields are optional. Arrays * if a JSON field contains an array, like the weather field, which is an array of weather objects, use a Swift array, weather. Time interval * openweather API often uses Unix timestamps to represent date and time. Time interval is a double that represents the number of seconds since the reference date. Asterisk nested objects. Asterisk the structs can be nested to match the hierarchical structure of the JSON. Step 2. Making the network request. Now, let's create a function to fetch data from the openweather API. Explanation. 1. Create the URL asterisk. This builds the URL string for the openweather API endpoint using the latitude, longitude, and your API key. Remember to replace placeholder your _API key with your actual key. I have also included and units equals metric to retrieve temperature in Celsius. 2. Create a URL session asterisk. URL session is used to make network requests. URL session.shared provides a default session. 3. Create a data task asterisk. A data task is used to fetch the data from the URL. It takes a completion handler, a closure, that will be called when the data is received, or when an error occurs. 4. Handle errors asterisk. Inside the completion handler, first check if there's an error. If there is, call the completion closure you passed in with the error. 5. Check the HTTP response asterisk. Ensure that the HTTP status code is in the 200 to 299 range. Success. If not, create an NS error and pass it to the completion closure. 6. Check for data asterisk. Make sure you actually received data. 7. Decode the JSON asterisk. Asterisk. Create a JSON decoder. Asterisk. Call decoder.decode, weatherdata.self, from, data. This attempts to parse the JSON data into a weatherdata object. The weatherdata.self tells the decoder the type of object to create. Asterisk. If the decoding is successful, pass the weatherdata object to the completion closure. Asterisk. If there's an error during decoding, example the JSON doesn't match your data structures, catch the error and pass it to the completion closure. 8. Start the task asterisk. Task.resume, starts the network request. Important, data tasks are created in a suspended state, you must call resume, to start them. Step 3, using the data. Now, let's call the fetch weather data function and use the parsed data. Explanation. 1. Import Swift UI asterisk for view purposes. 2. Set up UI elements asterisk. Created text views for displaying temperature and description. 3. On appear asterisk. This modifier ensures that the fetch weather data function is called when the view appears. Or, you might trigger it from a button tap, etc. 4. Latitude, longitude, API key asterisk. Replace the placeholder values with your desired latitude, longitude, and API key. 5. Call fetch weather data asterisk. Call the function we defined earlier. 6. Handle the result asterisk. Asterisk. Check for an error. If there's an error, print it and update the UI. Asterisk. If you receive weather data, extract the relevant information, temperature, description, and update the UI. Asterisk. Use optional chaining, weather.first.description, to safely access properties of optional arrays or nested optionals. Important considerations and best practices. Asterisk. Error handling asterisk. The error handling in the code is basic. In a real app, you'd want to provide more informative error messages to the user. Asterisk. Asynchronous execution asterisk. Network requests are asynchronous. This means the fetch weather data function returns immediately, and the completion handler is called later when the data is received. The UI updates must happen on the main thread, which is why the dispatch queue.main.async is used. Asterisk. UI updates asterisk. Never update UI elements directly from a background thread. Always use dispatch queue.main.async to ensure that UI updates are performed on the main thread. Asterisk. API key security asterisk. Never hardcode your API key directly into your app if you're distributing it. This is a security risk. Use environment variables or a more secure method to store the key. Data validation. You might want to add additional validation to ensure that the data you receive from the API is within expected ranges, example temperature is within reasonable bounds. Background tasks. Consider using background tasks for long-running network requests to prevent your app from being terminated by the system. Caching. If you're making frequent requests to the same location, consider caching the weather data to reduce network traffic and improve performance. Running the code. 1. Create a new Xcode project, iOS or Mac OS. 2. Copy the code into your project, the structs, the fetch weather data function, and the UI code. 3. Replace the placeholder latitude, longitude, and API key with your actual values. 4. Run the app. You should see the weather information displayed in the UI. Check the console for any error messages. Debugging tips. Print statements. Use print statements to debug the code and see the values of variables. Breakpoints. Set breakpoints in Xcode to pause the execution of the code and inspect the values of variables. Network inspector. Use Xcode's network inspector to monitor the network requests your app is making and the responses it's receiving. JSON validation. Use a JSON validator, online or in your code editor, to ensure that the JSON data is valid. This comprehensive guide should help you understand how to parse JSON data from the openweather API using Codable in Swift. Remember to consult the openweather API documentation for the most up-to-date information about the API endpoints and data structures. Good luck.